Hi, recently I watched a YouTube video from the Walt Disney Imagineering team, and they presented a bipedal robot inspired by the BD-1 droid from Star Wars. Not only is it able to maintain impeccable balance while moving around using its two legs, it does so expressively, in Disney-style characteristics through the robot's gaits and traits. Disney presented this cute free-roaming robot as just one prototype of applying their reinforcement learning hardware-agnostic approach to providing functionalities and expressive motion styles to any new robot design. This allows very rapid design and deployment iterations, and people have already spotted a herd of them roaming inside Disneyland. Then I started thinking, can I try design one myself? Maybe a simulation model as the first step. First of all, do I possess the skills to sketch a design? Make a model in 3D, and add surface texture to it? After a disappointing round of self-evaluation, the answer is a resounding no. But lately I have also seen various types of AI enabling unskilled people like myself to do impressive things. In this video, I will try to generate a bipedal robot model using free AI tools, and see what I can get. Most generative AI models output pictures. So, let me get myself a 2D design first. Popular image generation AI include OpenAI's DALL-E, Midjourney, and Leonardo AI. I will use Leonardo.ai here, because it is freely available to the public. On its front page, I can browse the different models they provide, and see descriptions of each's visual style. This Albedo Base XL model generates CG-like graphics, which is exactly what I am looking for. In the prompt, I will type, a robot character in the style of Star Wars. Well, I have only watched a couple Star Wars movies, and none of them are recent. But I like Guardians of the Galaxy, so I will also add it to the mix. Click Generate, and let's see what I can get. Neither of the two are perfectly matching my expectation, but it is definitely working in the right direction. So, let me generate 4 more pictures. The picture in the middle looks pretty good. It even has 2 smaller characters on the side. The one on the left is in Star Wars style, and the other is, well, Star-Lord with Rocket's head. Let's crop out the main character in the middle and proceed to 3D model generation. Let's go to Google and find out some options for image to 3D model there. From the search, I found a website called Alpha 3D that allows me to create a 3D model of a shoe from an image. But sadly I cannot get it to work on anything else that is not a shoe. Then, I found an AI tool that interprets the scene from an image and adds a depth map to render it in 3D effects. But it cannot generate a complete mesh object. The next one I found is called Kinematics, which generates game-ready 3D assets from 2D images. Other people seem to have got very good result from it, and the results they demo at the website look very high quality. But it is a paid service. For occasional use, it is $20 per model. Finally, I landed on this website. It is a model called Dream Gaussian hosted on the Hugging Face platform. It is able to generate some decent mesh models from just one front view image, although not as high quality as those shown on Kinematics, but the best part is it is free. So, big shout out to the team that developed this model. Now I upload my 2D image, and just wait for the magic to happen. First I get a rough model, what they call stage 1. Wait a little longer, and I got my final model. Since I only have one front view image, the model was not able to separate the robot's head, neck, and body. But for the most part, it did a great job. After downloading the 3D model, I can inspect it in more detail in Blender. A professional 3D model artist will now jump in and perform touch-ups on the model. I do not have such skills. So I will just move on to the next step. Currently, my mesh model is just one big rigid block. Let's add movable joints, aka adding kinematics. This is how a Blender expert would do it. Wow! But I have no idea how to do that in Blender. I am an old-school robotics guy, so I will do the kinematics in CAD instead. I like using Onshape for quick CAD modeling, because it lives in the web browser, is easy to use, and you have guessed it, it is free. I will create a new project, and upload the 3D model. One thing I noticed right away is that the surface texture is lost once imported into Onshape. This is no surprise, as parametric CAD software usually only have very limited functionalities on mesh models. They are no replacement for applications like Blender. What it means is that I will use the imported mesh only as a reference for constructing the kinematic skeleton, and later, I will need to combine the CAD skeleton with the original 3D model, the one with texture, elsewhere. I also noticed that the surfaces are not very smooth, with multiple bulges that look disgusting. So let me switch back to Blender and do some quick cleanup using my super elementary Blender techniques. Now it is looking much better. Back to Onshape, using the mesh as a reference, I will sketch some simple shapes to approximate its skeleton in 2D. Then create 3D parts from the sketch. All the joints are rotational type, and I added cylindrical features at joints that connect two separate parts to make the subsequent assembly step easier. These created parts represent independent links of the robot's kinematics, and they are constrained by joints, which I will add now, in assembly mode. Once all the degrees of freedom have been added, there are tools to export the kinematic robot model to some standard definition format in the robotics world. One last step is to split the original 3D mesh model into individual body parts so that each part of the robot is able to move with its attached kinematic link. This is very straightforward in Blender. This is it. A fully articulated bipedal robot ready for simulation. Well, maybe I should have constrained the range of motion for each joint in a more realistic way. And finally, we are ready to put the freshly generated robot into physics simulation, just like how those Disney robots are trained from the beginning. That is the first step, before they are tested and deployed on real hardware in the real world. Ouch. But of course, all I have done so far is construction of a robot model. I still haven't touched the other half of the picture, which is control. But it is a good starting point for me to keep exploring. That's it for now, and more playing to come.